the inverse of any orthogonal matrix, you simply can make it equal and write it. And generally MCQ questions can be asked on this topic. So yeah, prepare yourself. I'm telling you before the hand. Equality of matrices. So if you are making any matrices equal, like you are solving any equation, and in generally equation solving they make it equal. So for the matrices to be equal, their orders should be same. That is the very first condition. The second condition is the elements of A with the corresponding to the elements in B. Like if it is A1 in A1 and B, the element we are talking about A, B, A1, then A is equals to B. This is the condition. You have to make each elements also equal, and also the order should be same. Algebra of matrices. So if A and B are the two matrices of the same order, the sum can be defined only when, see, sum is only possible when they have same order, and product is possible, later we'll see. So the first, like it is 2 into 2, B is 2 into 2, then it gets added up, and again the order is 2 into 2 of the added matrix. Properties. Matrix addition is commutative. These are basic properties that you should know. A plus B is equals to B plus A. Everybody knows this. Like normal. Matrix addition is associative. This is the associative property you had studied in class 8, 9, additive, cumulative, additive identity, multiplicative identity. These things were you've already studied, so we'll just having revision now. Now is the existence of additive identity. So how the additive identity is existing, we can know it very well. If O is a matrix of order m into n, whose elements is 0, all the elements is 0. So any matrices when added with that 0 matrix is equals to A only. Okay, that's normal additive identity. So this is the additive identity. Like 0 was the additive identity in normal algebra, and O matrices is the 0 identity for the matrices. Existence of additive inverse. Let A is equals to this, then the negative of the matrix is defined as this way. So to make it 0, we have to add it with A plus minus A is equals to 0. That's why the additive inverse of A is minus A, and of minus A, the additive inverse is A. Cancellation law holds good for addition. If A plus B is equals to A plus C, then B is equals to C. Very simple. K, any constants is multiplied to the sum, then we get K. You can also multiply it individually like this. Subtraction of two matrices. Let A and B be 2m into n matrices, then the difference of A and B is denoted by A minus B and is defined by A minus B is equals to A minus B. This and this, both things are same. You can subtract two matrix, or you can take addition of one matrix and then the negative of that matrix and add them. Simple. Multiplication. Now we are at the multiplication. So the product of a matrix A by the scalar K is a matrix whose element is K times this. So this was some number, this is becoming this. So a constant got multiplied, it very simple, K into matrix is equals to K A go like this matrix. Very simple. Properties of scalar multiplication. If A and B be any 2m into n matrices and K is any scalar, then this is the it holds for this. I hope you can see. Now it must be visible. So if A is any m into n matrix and B are the two scalars, then this holds for this. Yeah, basically you're just multiplying a scalar to the matrix. It's very simple. Multiplication of matrices. Now the real multiplication comes, where you are multiplying two matrices. When you're multiplying with this scalar, it was very easy, very same. But when you'll be doing it with in this case, when you're doing it in this case, then you have to look after some rules. The first one is that the the number of the rows, suppose it is the number of rows, it is the number of column of matrix A, and matrix B where number of rows is this and number of column is this. So for multiplication to be possible, number of columns should be equal to the number of rows of the second, that is C1 is equals to R2. I hope you're getting it. And then after multiplication, what you get a new matrix whose uh, order will be R1 C2. So you can get it now. The product of matrix this, it is becoming this. It's very simple. But if the matrix, the order of both the things are same, like rows and column rows, everything is same, in that case it will be this normal. You just have to like multiply it by one rows by the column, this rows by this column, and another row by the another column, then rows by another column. That's what it has. Like, 1 2 3, 1 2 3, 3 1 2 3. Suppose we have two matrices. Okay, so first we'll be multiplying this column with this and right here. Then we'll be multiplying this column with this and right here. Then we'll be multiplying this column with this and then it will right here. Then we can multiply this column with this column, write it here. This column with this column, write it here. This column with this column, write it here. Third column with the very first row. Third column with the very second row. First column with the third row, and here we get again 3 into 3. Simple. Like that we have to do other one also. It's simple. So if A and B, we are multiplying it, and this is same. Okay, don't get confused. This is what I'm doing it right now. When you find the sum of everything, the two terms like this, then you will write it this way. You're multiplying this by this means first term by this, second term by this, third term by this, and you're adding them only. So if AB equal to 0 is a null matrix, 0 is a null matrix, it depends necessary implies that A and B is a null matrix. Means either A was 0 or either B was 0. If it is coming out to be a null matrix, then either A or B, either one of them is null matrix for sure. For instance, A is equals to like this, B is equals to this. Then neither A nor B is a null matrix, so it can never give you 0. Although neither, there is any, like according to this question, if the point is this, then its inverse is not possible. Okay, it is 0, that doesn't, if any one of them is 0, then surely this will be 0, this you can say. But if it is 0, then you cannot say that any one of them is 0. That's why I'm trying to make it understand. Now listen me. If this is 0, that doesn't mean any one of them is 0. But if any one of them is 0, then definitely this will be 0. Okay, so next, multiplication of matrices is not always commutative. Multiplication commutative is not always. Like AB is never necessarily equal to the BA. Multiplication matrix is associative also. Associative means you're just taking brackets differently, applying different places. So A, B, C can be M into N, N into P, P into Q, like that it should be. I hope you know. So each of them is matrices, it's possible, like is associative. You can multiply these two and then these two and then with the A. Both will be correct. One more property here we have is multiplication is distributive of matrix. Suppose A is this, the order of the A matrix is this, B and C have both this matrix order, then you can use this is distributive. Suppose B plus C is distributive, then they should have same parametrics. Okay, because for addition it's necessary that both the orders should be same. That's why these two should have same order. When you're multiplying it with this, you can either do this, you can multiply this, and then you'll also get the same order. So yeah, it will be plus. You plus is possible. That's why it's always distributive. Multiplication of a matrix by unit matrix, then you'll get the same matrix. Simple. Multiplication of matrix by null matrix, you will get 0, of course. Inverse of a square matrix. This is important because in questions it's asked find the inverse. I hope you know how to find the inverse. Like there is a process. Okay, I'll tell you. Actually, there are a lot of ways to find the inverse matrix, but I'll be telling you the easiest method which you have not studied in your NCRT. Like you would have studied a different method in NCRT, and even there is a trick also where you make boxes and then you find the inverse. But for me, that's really big. Even the NCRT one is very big, but if you want to solve like equations with, even you forget the process sometime. Okay, this is the step, I forget that stuff. So I remember this process. It's very easy, which is called row transformation or column transformation. Suppose if A is a matrix and you have to find its inverse, then we know this is the very important property. Always true, holds true. So yeah, we put the A and then we put an identity matrix and again we put A. Hmm. So now you have to make this A, convert it into this identity matrix by using row transformations. So like R2, we have done R2 plus R1. Instead of R2, we are writing R2 plus R1. So minus 1 plus 1, it will become 0. Like you can see. And 3 it was there. So again 3 became 5. 3 plus 2. So it's doing this way. And here also I'm applying the same thing. Now I'm making R2 is equals to R2 plus 3R2. The R2 is equals to R2 plus 3R2. Again it becomes 1. 5 into minus 6. So it become 1. Yes. 2 into minus 3 plus 3. It becomes 0. 2 into R3. As you can see. Okay. So this is how we get this one line we have made into a diagonal like of identity matrix. Then similarly we have to apply on R1 and R3 also to make it like this. So what I'm R2, I have written R1 minus 2R2, and in R3 I have applied R3 plus 2R1. So here we get this one. And while applying the same thing on the right hand side, you get this thing. So this becomes your inverse. Simple. It's very easy. Actually, you cannot see, right? Yeah. So yeah, we just applied this, became this equation. But now I want it to be 0. So what I will do is multiply it by this. Simple. The one was this, 1 into 0, it will become 0. R1 plus 2 R3. R1 plus Z. So it was minus 2 plus 2 into 1, so it becomes 0. That's what it being done. That's why it's very easy method, because it will take time. You have to use your brain, and sometimes it will not follow, and if you don't have practice, then it will take a lot of time for you. So it's better you learn all the steps and solve by using that method only. But if you are very good with the matrices, then definitely for sure use this method. It will be very easy. So yeah, thank you, and this is the last part. We'll meet soon.